Let's see. All right, for problem 96. Problem 96. Let's start with this. Okay. Problem 96. Okay. Problem 96. Let's begin with the Jacob. Have you tried this, Jacob?
1 second. Let me get to that page.
Okay. Let's see. Jacob.
No, but I can do it right now, actually.
Okay. So let's see. There are two things to be considered. For this example, 96, it's a race. Okay. 6 cars are entered, no ties. Okay. So here is no ties. How many ways? First 3 finishers come in. Okay. So no ties. Is there repetition?
There is no repetition.
Okay. So no repetition. Does order matter?
Order does matter because it's a race.
Okay. Order matters. So it's MTR. Now we need
120.
Okay, so we have, how do you get 120?
You have the first 3 spots, so first, second, third, and then instead of it being, because there's 6 automobiles, if there was repetition allowed, it'd be 6 over 1 over 2 over 3 over 4 for the spots.
Okay.
So then, but there is repetition, so it's 6, 5, 4, and then you multiply 6, 5, 4 together.
Okay, so let's see. So here's one way to do it, MPR. Simple enough. There are 6 cars. We choose the first 3. Okay, 6 permutation 3. This is one way to find it. And you use calculator, 6 permutation 3, 6P3. By using calculator, what do we have? See, 6P3.
120.
120. Okay, so 120 ways to find. Okay, let's see. Is there any other ways to find? Let's see. Number 2. I'll show you another way. Okay, MPR, you can do this. It's order matters, so you can put a bar. How many ways can you pick the first position? There are 6, so 1 car came in. Okay, how many ways can you pick the second position? There are only 5 cars left, so 2 cars in. So how many ways can you pick the third position, which is a 4? So you multiply this together, 6, 4, 5, you still have 120. So there are a couple of ways to do it in permutation case. Combination, you don't have many choices. You only have one choice to do it. But permutation, there are some ways to do it, okay? So you can use MPR directly, or you can use a bar and multiply. That's one way to do it. All right, let's move to problem 97. Okay, Tyler, have you tried this?
Yeah, I did give it a shot.
Okay, try.
I believe it's also 120.
How do you get that?
5 permutation 5, and that's I did it because order does matter. Yeah.
Okay, very good.
And
so
yeah.
5 singers, okay, 5 singers of a weekend evening. I don't care, it's a Saturday, Sunday, it's a weekend, okay? So as Tyler said, we have no repetition. Okay, order matters. Concert, all those programming order matters. So permutation, MPR. And how do we write it? There are 5 singers. All 5 singers are play. So 5 permutation 5. So it has a different argument when you compare to the previous one. The argument was a 6 permutation 3 because there are 6 cars. We took first 3. Here, 5 singers. We took 5 singers. Okay, still 120. Is it what Tyler says? Okay, that's one way to do it. One way to do it. Okay, let me show you another way. Permutation, you have a couple of ways to do it, as I said. So I put 5 bars. It's because of a concert. 5 bars. How many ways can you pick the first singer? There are 5 ways, and the one singer's already sung. And then there are 4 singers left. 3, 2, 1. You multiply this. Okay. And you also get 120. And then number 3, as you see, we have a 5. We pick all 5. That's exactly same as 5 factorial. And that's also 120. So in permutation, there are some ways to do it. It's not only one way to compute, but what's the most important thing? The most important part is finding this guy, the repetition order matters. So these guys are extremely important, but the other 2 can be done also, okay? So combination, a fundamental counting principle, those are no other ways to do it. Only one way to do it. Here's one question, only one way to do it. But in permutation, you have some ways, some other ways to do it. Are we okay with this? All right, let's move to problem 98. Okay, so I'm moving on, problem 98. All right, let me see. Anyone tried problem 98? Patrick Gallant, have you tried this?
I tried it, but I'm not sure if it's correct.
Okay, we'll try, let's guess.
So I was talking about the stocks and how it can go up, down, or stay the same. And it was asking how many possibilities are there if you own 7 stocks. So I did wrote out like 7 lines, and then I did the 3 different ways they could change.
1, 2, 3, 4, 5, 6, 7. Is that what you say?
Yeah, and then I did
2, number 3, number 7. Okay.
and
Okay.
then I just put 3 in for each because of the 3 different ways.
Very good. You are excellent. You did it correctly. Okay, this is the correct way to do it. And then you multiply it. That
And
is
we got 2,187.
87. Excellent. You did a great job. This is a fundamental counting principle. Okay, fundamental counting principle. There are 7 independent stocks. So stock number 1, let's say that's Apple stock, could go up. Stock number 2, let's say Facebook, okay, maybe go down or maybe stay as unchanged. You know what I mean? So it does have all different groups. So this is fundamental counting principle. It could be everybody can go up, everybody can go down. So it does need a possible repetition. You know what I mean? So maybe not every stocks can go up, down, and unchanged. So which is really good. So you guys studied. All right, very good. Let's move to next page.
Sorry, I have a question on this. How did you get the denominator on them? Like 51, 52?
What's denominator? S1, S2?
Oh.
Are you talking about this? Is not denominator. I just mentioned this is a stock 1. Stock
yeah, I thought that was a 5. I'm sorry.
Sorry, my writing. It's stylus. Sorry. Okay. It's not denominator. Okay. It's not 57. It's S7. All right. Let's move to the next one. So problem 99, problem 100. It's both also homework from last class. So let's do it. Let me just look at the background here. All right. So let me make it big. Let's see how we can do. Make it bigger here. All right. This is good enough. Okay. Problem 99. Okay, problem 99. All right. So there are 3 parts. So it's the same 7 seats, but 3 different ways to cushioned. Let's do the first one. 7 seats positioned. A row of movie theater. So Alice, Betty, Craig, Dan, Evelyn, Frank, Gavin, A, B, C, D, E, F, G sits together in a row. How many different ways they can be arranged? How many ways they can be arranged? Okay. 7 friends sits together in 7 sits. Okay, 7 friends sit together in 7 sits. So repetition. Can one person sit more than 1 sit? No, no repetition. 1 person per 1 sit, okay? Does order matter? Sits together, does order matter? I said order matters. It's because of Alice and Betty are closer friend. They want to sit together instead of they sit in like 5 parts away. You know what I mean? So even though 7 friends are sitting together, order matters. Who sits next? Who sits next? Okay. So there are a couple of ways to do it. So I want to show you. No repetition. Order matters. So it's a permutation. Now, 7 friends, all 7 friends sit together. Like 5 singers, all 5 singers play. Okay, so some of you have a calculator. I want to get a number. What's 7? Permutation 7.
It's 5,040.
Okay, 5,040. That's one way to do it. Next, Jacob. And the next one, so it's 7 sits. 1, 2, 3, 4, 5, 6, 7. Okay. Sit number 1, I have 7 ways to do it. Sit number 2, 6, 5, 4, 3, 2, 1. So everyone can sit. You multiply all this. You also get 50, 40. That's exactly same as 7 factorial, which is 50, 40. That's by definition of a factorial. So this example, we are able to do like 3 different ways that we practiced from previous example. No problem. But problem like this, okay, 7 sits and friends are sitting together. What is the best way to do it? I mean, nothing wrong with this permutation. We get an idea, but the easiest way you can do is this. Okay, the easiest way you can do is make a line and who sits what. Okay, this is the easiest way. So problem like this, I highly recommend this way. It's not too long, but this makes avoid our silly mistakes. So you can do it. Let's do number 2. How many different ways can be arranged if Betty sits the second? Okay, so Betty wants to sit that particular sit. It does have an extra handle or maybe extra cup holder or whatever. So Betty wants to sit second and everybody else can sit wherever they like to. So 1, 2, 3, 4, 5, 6, 7. And Betty wants to sit right here. So she wants to fix the position. Okay, so how many people left? There are 6 friends left. So 6. Betty sits here. 5, 4, 3, 2, and 1. As you see, this is the easiest way you can do. Or we can just 6 move together. So 6 factorial, that's another way to do it. So we have a 6 factorial. 6 factorial, you have a calculator. $720. Okay. Just quick question. We all okay with using calculator? Holly, you okay with the calculator?
Yep.
Yep. Okay. Calculator. Okay. All right. All right. Question. Let's move to number 3. How many different ways? Okay. if Craig and Gavin wants to sit 2 aisle seats. Okay, so okay, 1, 2, 3, 4, 5, 6, 7. These 2 are aisle side. Okay, 2 aisles. Okay, so right here, 2 aisle sides. So Craig or Gavin wants to sit here. Craig or Gavin wants to sit in here. Okay, so those 2, I don't care, those 2 folks, they can sit whatever they do, but remaining 5 friends can sit in the middle aisles. So there are 5, 4, 3, 2, 1. Those are friends, okay? We don't care, you sit in the corner, okay? We'll sit together in the middle aisle. Now, how do we compute for 2 aisle sides right here? So here's the thing. If Gavin sits here, Craig has to be here. That's one way. If Craig sits here, Gavin sits here. So one person sitting here, and then next person automatically goes in here. So at this position, Craig, either Craig or Gavin. So there are 2 ways to choose. Agree? There are 2 ways to choose. So somebody sits in this aisle, and then automatically the next person sits the other aisle. So I want to say there are 2 ways to sit. Either Craig or Gavin. So if Craig sits here, Gavin has to be here. Gavin is here, Craig is here. What do we do with these numbers? We multiply. And you get the number. Anyone?
240.
240. Turn 240, 240. Okay. So based on these 3 examples right here, so it's one question, problem 99. It's one question right here. It's 7 sits, those 7 friends are sit together. It's depend on the question type, the solutions changed. So as I said, this type of question, make a bar. This is easiest way you can do. Okay, this is easiest way you can do. All right, let's move to problem 100. Okay, problem 100. There are 17 balloons, 3 blue, 5 red, 2 green, so on and so forth. How many distinct ways can balloons be arranged? How many distinct ways can balloon be arranged? This is similar to what we had it from rearranging the letters, Mississippi, Massachusetts. Okay, so 17 balloons, you're thinking as it's 17 letters. Do you understand this? So there are, okay, repeat it. So we have 17 factorial divided by 3 blues, 5 red, 2 greens, 3 yellow, 4 orange. Okay, don't forget the parentheses. Okay, I give you a minute. Those of you have a calculator, I want you to compute and give me a number. Don't forget the parentheses. If you don't put the parentheses, answers might be different. Okay, so go ahead and change parentheses. It's really long number. It's big number.
Yeah, that's a huge number.
Okay, Jacob, what do you?
I got 1715313 600.
Like that?
Let's double check.
Are we agree with this?
Yep, that looks right to me.
Okay, we have that many. Okay, it's 1
I agree
billion.
with that. I got that as well.
Okay, it's 1 billion. Okay, a lot of ways. Okay, so don't forget the parentheses. If you don't put the parentheses, if you miss this parenthesis, number is way bigger than that. Okay, way bigger than this. Any question? Okay, so again, 3 things are needed. Repetition, order matters, okay? Repetition, order matters. Repetition, order matters. Okay, fundamental counting principle, permutation, combination. Those are 3 choices, okay? I want to put on the side. Okay, so those 3 are, see, okay, those 3 are what we need, okay. Try do problem 101. All right, let's see. Jeremy, have you tried 101? You did?
I have not. I'm
Have
sorry.
Okay, so let's do it together. Problem 101, 102. I think I forgot to assign these 2 problems. I want you to think of this problem 101 and 102, and let's do it together. Okay, so 2 things. Repetition, order matters. Okay, repetition, order matters. 2 things. Go ahead. Problem 101 and 102, and I want to scroll down for the remaining questions. Okay, so let's go back to problem 101. Okay, 3-person committee is need to study ways of improving public transportation. How many committees? So here is a word, committees. Committees, okay, 3-person committee. So if it's a human being, no repetition. So it's clear, no repetition. Committee members, no order, okay. As I said, if it is a position like president, vice president. Oh, by the way, tomorrow is election day. Don't forget to vote. Order does not matter for committees. Okay, so it's the same kind of stuff, but if it says, I want to choose president, vice president, treasurer, secretary, and so on, the positioned order matters. If it's just committee members, order does not matter. All right, so here, no. So it's NCR this time. Now, bigger number comes first, small number comes after. So we choose 3 out of 8. 8 combination 3. You have a calculator and you get the number. Okay. Pat Gallant, do you have a number?
Would it be 56?
56. 56. Pat, you're doing good with this probability. Have you had done this before?
No, I've never done this before.
Yeah, but you're doing very good here. Okay, I'm impressed. All right, let's move to problem 102. Okay, so again, here is a pet sit. Your friend has 7 different animals. I don't know what kind of 7 different animals. Okay, 7 different animals. Okay, you want to take a 3 of 7. Okay, no repetition. You don't pick the same animal twice, so no repetition. Again, order does not matter which one you pick first. NCR, there are 7, we pick 3. Holly, do you have a number for that? 7 combination 3. Just want to double check if you have a calculator.
I got 35.
35, we all get 35. Okay, 7 combination 3. There are 35 ways to choose. Okay, let's move to, before we move to down here, I put this deck of cards right here. Okay, so let's just go over the stack of cards right here. Many of you know. There are 4 suits. Okay, so here is what is this called? Clover. Okay, and we have spade, diamond, excuse me, heart, and the diamond. So 2 are red suits, 2 are black suits. Ace to 10, jack, queen, and king. Okay, ace to jack, no jokers. Okay, ace, we put this as a number card. Jack, queen, and king, we put this as a face card. Here is a number card. So ace to 10 is number card. So there are 10 number cards and 3 face cards for each suit. Okay, so it's a 13 total and the 4 suits. So 13 times 4, there are 52 cards. 52 deck of cards. Are we okay with this? 52 deck of cards. All right, so ace we consider as a number card. Face cards, jack, queen, and king. Okay, so we have clover, spade, heart, and the diamond. Okay, clover, spade, heart, and diamond, and this is the deck of cards. Okay, deck of cards. All right, let's look at problem 103 of the bottom of the page right here. In poker game, a person is dealt 5 cards with a standard 52 deck of cards. So standard 52 deck of cards, 52 cards, you pick 5 of that. Okay. The order in which you are dealt 5 cards does not matter. How many different 5 cards poker hands are possible? Okay, cards poker hands possible. Okay, so it's already given. Order does not matter because you are holding 5 cards in your hand. Order does not matter because you're holding 5 cards, right? So whether you are holding ace or jack and ace, you still have the same 5 cards in your hand. So order does not matter. Now, it didn't say about the repetition. Can you pick the same card twice? You're holding 5 cards in your hand. Can you pick same card twice in your hand?
You could pick the same card 4 times.
Yeah, 4 times, but in one hand, you cannot pick the same card, holding 5 cards. So no repetition. Since it says order does not matter, no order. So we know this is combination. Okay, we know this is combination. So in poker game, how many different 5 cards poker hands are possible? So we have NCR, there are 52. We pick 5 of those. Okay, and then you have a calculator to calculate. Okay, 52, combination 5. 2, combination 5. Tyler, do you have a number?
I do. It is 2,598,960. I mean, 960. Yeah, after that.
Okay. This is general 5 cards in hand. But and then when you play a poker game, you have royal, flush, straight, and there are many others, right? So you can also compute that part too, as it's combinations. It's all this combination can be computed, and then we move to the probability, and that's the idea of computing a poker game. All right. So when you watch those the movie, I forgot the title of the movie. Those people, those students in MIT, was it MIT students? They actually calculated all possible probabilities in the poker game, and they played. And actually, the movie says they played in Las Vegas. Those people, the MIT students, actually they went to Atlantic City in New Jersey. Okay, so let's try with problem 104. How many different 4-card hands can be dealt from deck of 16 different cards? It's not deck of standard card. It's a 16 different cards. We are dealt 4 cards. Okay. Can you pick the same card? If 4 cards hand, another way to say you're holding 4 cards in your hand. Okay, so no repetition. Okay, you're holding 4 cards. Order does not matter. So combine together, it's a combination. No. So NCR, that implies 16 cards, we pick 4. Then you have calculator, 16 combination 4, you have number.
1820.
Okay. 105. Election bullet ask 3 city commissioners from group of 6 candidates. Okay. Order does not matter. Combination. So 6, we choose 3.
$20.
20. Thank you. All right, so let's scroll down for 106. Are we okay with this? Is this too fast? No, okay, good. Problem 106. Okay, US Senate of 107th Congress consists of 50 Democrats, 49 Republicans, and 1 independent. Yeah, okay, so Senate. Okay, 2 per state. We have 50 states. So 2 times 50, it's total of 100 Senate for United States. Okay, 100 Senate, United States. House of Representative, I think we have 430 something. I don't remember exact number. So House of Representative, it's about 430 some and 100. So altogether, Congress has a 500 something. Okay, so those are the number of Congress in the United States. By the way, how many committees can be formed if committee must have 3 Democrats and 2 Republicans? So it's clearly shown, not just the 5 committee members, we want to show particular 3 from the Democrats, 2 from the Republicans. Another way to say we have 2 different groups. So here's a group 1 for Democrats. Here's a group 2 for Republicans. Okay, Democrats and the Republicans. All right, so we choose 3 Democrats out of 50. No repetition, order does not matter. Remember, committee members, order does not matter. So it's a combination. There are 50, we pick 3 from the Democrats. And the Republicans, we have 49, we pick 2. You multiply this together. So this is the first time you see fundamental counting principle as well as combination. It does possible you could have a combination, permutation, and fundamental counting principle all together. So this is first time it's mix everything together if it has 2 different groups. Okay, so group of Democrats, group of Republicans, and we pick this. Okay, so let's see. 50 combination 3. So let's first compute Democrats. Compute this part. What number do you have? Okay, so 19,600. Okay, the next one, 49 combination 3, 2. I have 1176. You multiply that together. Okay, 23049,600. Okay, so there are many ways to do it. Question? No question. Okay, so I want to move next page. problem 107. That was a part of homework for the weekend. I don't know how many of you tried. It has how many parts? Okay, 15 parts. Okay, so let's do one at a time. So let's do page by page. So let's try the first page. Okay, so 107, 1, 2, 3, the 3 parts. Go ahead and do this. And then let's continue. Okay, so try problem 107. You guys have a notebook or the PDF file in front of you, so you're able to look at it instead of okay, very good. I scroll up and down. How many of you are depend on the screen that I projected? Okay, Thomas. All right, so go ahead, problem 107. Problem 107 is on page, okay, 134. Okay, page 134. Problem 107, page 134, and the 135, and so on. So you can keep on moving on. Okay, so if you're done with the first page, move on to the next page and so on. But I want to cut off for page by page. So let's start with the first 3 pages. I give you 5 minutes and then move to the next 3 and then so on and so forth. So let's do that. Okay, so go ahead, try it. Okay, so let's do with the first page here. Okay, so number 1. Okay, number 1. Let's see. Patrick, what do you think?
For number 1, I have 12.
12. How do you get 12?
With the 3 colors and the 4 tips, I just multiplied 3 times 4.
Okay, 3 colors and the 4 tips. So we have 2 groups. Here's a color group and here's the tips. So 3 colors, 4 tips, multiply together, 12. Fundamental counting principle. Very good. Okay, straightforward. 2 different groups. Let's move to number 2. How many 4-digit odd numbers? 4-digit odd numbers. 4-digit odd numbers. Jeremy, have you tried this?
I had 4,499.
Okay, how'd you get that?
Yeah, is that wrong?
I don't know. How did you get this number? It's close enough, but I wonder, how do you get this number?
I subtracted 1,001 from 9,999 and I got 8,998 and I divided it by 2.
Okay, so actually computed, I counted. Okay, so let's see. So let me do the Jeremy's way. I mean, nothing wrong with that. That's clever. So let's look at this. 4-digit odd numbers. So let's just look at the 4-digit numbers. Okay, 4-digit numbers. So forget about word odd, 4-digit numbers. So the smallest 4-digit number you have is 1,000. Largest 4-digit number is 9,999, right? That's the largest of 4,000. How many are they? So 1,000, 1,001, 1,002, so on and so forth. So you're folding your fingers until 9,999. Nothing wrong with that. But how do you compute how many 4-digit numbers we can have? So let me make it easy for you. Suppose you have number 5, okay, through number 13. How many numbers from number 5 to 13? Inclusive, okay, so 5 to 13. How many are they? Most of us compute, 13 minus 5, we have 8 numbers. Agree? We have 8 numbers. So let's see, because this is the easy way you can compute by finger. Let's look at it. 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 9 numbers. Agree? I have 9 numbers, but when I compute this, it's 8. So nothing wrong with this. It's because you always compute for the first one. So you first add 1, so you get 9. So there are 9 numbers between 5 and 13, include both ends. Go back to this 1,000 through 9,999, 4 digits. How many are they? 9,999 minus 1,000 plus 1. It's because we have to include the first one. How many are they?
$9,000.
9,000. There are 9,000 4-digit numbers. 9,000 4-digit numbers. Half are odd, half are even. So half of this, 4,500. Okay, half this. So this is what I said, Jeremy. It's close enough because you just missed one. It's because you forgot to compute the first number. So you have this. All right, so this is one way to do it. I mean, nothing wrong with this, but we didn't use anything with our professional formula. So let's use the professional formula. I mean, nothing wrong with this. This is number one way to do it. Okay, I like it. But let's do our professional way. Okay, so here is professional way number 2. Okay, number 2, 4 digits. 1, 2, 3, 4, 4 digits. Okay. So to be 4-digit, first digit cannot be 0. It has a 1 through 9, right? 1 through 9. So there are 9 choices. Because as you see, here is a 1, 2, 3, 4, 5, 6, 7, 8, 9. You cannot have a 0 for the first digit, right? And when you look at the second digit and the third digit, there's no restriction. So there are 10 ways and 10 ways. Okay. To be odd number only depends on last digit. Okay, only depend on last digit. So for example, 2, 2, 2, 1, this is an odd number. Suppose 1, 3, 5, 4, this is even number. Even though all 3 digits are odd, depend on the last digit. You know what I mean? So how many odds we have? So odd number, 1, 3, 5, 7, 9. Okay, those are odds, right? 1, 3, 5, 7, 9. There are 5 ways. You multiply 4,500. Okay, so it's still fundamental counting principle, but this is another way to do it. So same idea, we can have a 3-digit even number and so on. So if you get the idea, then you can apply the many of those. Are we okay with this? So number 1 way, no problem, okay? I like it. Number 2 way, it's okay to do it too. It's because of the fundamental counting principle. It's a little bit professional way, and you just see, oh, it's a more mathematical way. I mean, nothing wrong with this. I accept both. I accept both, but make sure you know both ways. All right, let's move to number 3. Okay, election vote. Okay, city commissioner from 8 candidates. Okay, so 3 city commissioners from group of 8 candidates. How many ways can be done? How many ways can be done? All right. Let's see. Edwin, what do you think? Okay, I think he's out. All right, let's ask Holly. Is Holly here?
Yep. For number 3, I got 56.
Okay, how do you get 56?
I did 8C3.
8C3. Excellent. Okay, no repetition. Order does not matter. Very good. Okay, very good. Any question? No question. Let's move to next page then. Okay, very good. So again, 4, 5, 6. Okay, 4, 5, 6. Let me just make it a little bigger. 4, 5, and 6. Okay, go ahead and try. So problems are mixed. All right. Let's begin with Ed. So what do you do with number 4?
So since there's 6 singers, I did 6 times 5 times 4 times 3 times 2 times 1, which is 720.
720. We all get the same thing. So it is permutation, order matters. Okay, here's order matters. 6 singers, we have 6 shoes, 720. Okay, 1, 2, 3, 4, 5, 6 order matters, or we can say 6 factorial, that's also 720. As I said, permutation, we have many ways to do it. Okay, let's look at number 5. Let's look at number 5. Thomas, have you thought of number 5? No, okay, that's fine. Let's move to number 5. Tyler?
720.
Okay, again, 720. How do you get 720?
I did 6 with the explanation point. I forgot the name of for that.
Factorial.
Factorial, thank you. 6 factorial. Which, but another way you could do it obviously would be 6 times 5 times 4 times 3 times 2 times 1. But
All right, order makes difference, as you see.
right.
Order makes difference, so it's a permutation. So
Oh,
permutation 6, okay? Same thing, okay? Same thing. There are many ways to do it. So number 4 and 5, it's 2 different questions, but we end up having same answer, no problem.
Okay.
Same stuff. Let's move to number 6. Ice cream stores sells 2 drinks in 4 sizes and 5 flavors. Okay. 2 drinks in 4 sizes, 5 flavors. Okay. Jacob, have you tried 6?
I did, but I'm not sure if I got this one. So I did 5 permutation 4, which got me to 120, and then because there's 2 drinks, I times that by 2 to get 240.
Okay, so 2 drinks, 4 sizes, 5 flavors. Okay, 2 drinks, 4 size, 5 flavors.
Yeah, did you hear what I just said?
You did, but did you say factorial? This is not factorial.
Oh, I didn't say factorial.
Did you say 40? What did you say?
Oh, I said 240, so I got it wrong if you got 40. So I said 240.
Yeah, it's a 2 times 4 times 5, so it's a 40.
Okay.
Right? Yep, straightforward fundamental counting principle. All right, let's move to next page, 7, 8, 9. For problem 7, 8, and 9. Okay, so 7. Let's see, 7. Can try 7. All right. Patrick Gallant, do you want to try 7? Let's see how it works.
Yeah, so it was asking 5-digit keypad, and then the first I can't have 0 in it. But so I did the first spot was 9, and then the rest were 10. So I got 90,000.
90,000. Okay.
same.
Yeah, Tyler says yes. Okay, very good. Okay, very good. It's a fundamental counting principle. We're able to get something like my keypad. I can have a 1, 2, 2, 3, 1 like that. Okay, so we can have some repeated digits. All right, let's move to number 8. Okay. Let's do number 8. Any volunteer? Let's first ask for volunteer. Tyler?
So I get just to give it a shot. There's 10 multiple choice questions, 5 open-ended problems. You have to pick 8 of the 10 and 3 of the 5. So I wrote that there's no, since order does not matter in this case, it would be 10 with C. Why am I so terrible with names for this stuff? I'm sorry. Permutation C, right? Permutation.
Is it C or T?
It would be like NCR.
CR, okay, so it's
Yeah, CR. Yeah.
all right, so we have multiple choice questions, and here's open-ended,
Right.
and order does not matter. We choose
Right.
of 8.
Yep.
Not matter. We choose a 5, 3.
Right.
Very good. Order does not matter. We don't answer same thing twice, right? So like
Right.
that, and you multiply.
Right.
Very good. So what's a 10 combination? 8.
45.
Okay, what about 5 combination? 3.
10.
10.
Making the answer 450.
450 ways. Great.
That's good.
But yeah, very good. Very
All
good.
right. Excellent.
So we have 2 groups. One is multiple choice questions and the other is open-ended. And the multiple choice questions, there are 10 questions. You need to answer 8 of this. So I feel number 5 is easier. So I start with the number 5, then I answer number 1. That's okay. Order does not matter as long as you answered 8 of those. So combination. Okay, let's look at number 9. Okay, number 9. You're painting parking space. Okay. With the letter of alphabet and the single digit. So first parking space is A1. The last parking space is Z9. Okay. So how many parking spaces can you paint? So another way to say, here is a parking space. Okay, there are parking space in a mall. Now think about it, okay? So I start with A1, here's A2, here's A3, so on and so forth, B1, B2, B3, so on and so forth. I have Z9, the last painting. Okay. Are we okay with this? So it's distinct. Okay. That's how I paint. Okay. Let's see who can answer this question. Cassandra, Cass? We have here, here's a letter, there's a number. Okay. Cassandra, I can't hear you. Can you make the volume up a little bit?
I'm still working on it.
You're still working on it, okay. So this is A1, A2, A3, so on and so forth, B1, B2, B3, so on and so forth, and the Z1, Z2, and so on and so forth. Okay, so how many letters we have? We have 26 letters. How many numbers we have? We have 9 numbers. Okay, 1 through 9. Multiply. This is a fundamental counting principle. It's because it has 2 different groups, right? Can combine. So multiply this together. 26 times 9, 234. Let's move to next page, 10, 11, and 12. Okay. All right, are we all following? Okay, good. Page 137, 10, 11, and 12. Okay, so we have 6 more problems left. 10, 11, 12, 13, 14, 15. It's 15 questions, okay. So go ahead. Start with the number 10. Okay, so let's go back to number 10. Start with number 10. Let's start with Edwin. Ed, have you tried 10?
Yeah, just give me 1 second. So I think I messed up while doing it. I'm not sure if I did it right.
You can try.
Yeah. So I did the 100 runners and then, yeah, no.
Okay, now the question is, can you pick the same person twice? The answer is no. It's because it's no ties, right? It says no
Yeah.
ties. So no repetition. Does order matter?
Yeah, because there's 3
Okay. Order
winners.
matters. Okay. Permutation. All right. So there are 100. We pick 3.
Oh.
That's all you have to do. Do you have a number? Let's see. You have 100 permutation 3. 970-200.
Yeah. Thank you.
Let's look at number 11. Okay. Holly, have you tried 11?
I'm a little confused. I just left that one blank. I was just gonna wait until you went over it.
Okay, it's a committee members we choose, right? Committee members. We don't pick the same person twice. So no repetition.
Oh, would this be the 6C3?
Yeah, got it. Combination 6C3. Which is it 20?
20, yep.
Okay, 20. The question? Okay, let's move to, let me scroll up here. Okay, number 12. Okay, 9 comedy acts, 5 of acts were performed. Okay, how do you schedule it? Okay, repetition. Patrick, you can't hear us? Is it what you say? Oh no.
Well,
So
I think I
Patrick's
figured it out
saying-
now. I'm back.
Are you okay now? You can hear me?
I lost internet, so I'm on my phone.
Yeah, I'm sorry. It's just like some of us are come in and out for many times. I understand it's because of the wind today. It's very bad. So hopefully hold on for next 10 minutes. Okay, so 9 comedies, we choose 5, no repetition. Okay, programming, performance. Okay, any of those order matters. Okay, permutation. So 9, permutation 5. So 1, 2, 3, 4, 5. We just say 9, 8, 7, 6, 5. This is one way to do it. Or you can say 9 permutation 5. That's another way to do it. Then you have calculator to compute. 9 permutation 5. It's 15120. That's how you compute this. Same thing for those 100 runners right here. You can also put those bars. You see, permutation. You can always have 1, 2, 3. There's 100, 99, 98. Of course, it's all multiplied. You do have the same answer too. So in permutation, there are a couple of ways to do it. All right, very last one. Okay, page, the last page, page 138, 13, 14, and 15. Okay, so again, I give you 5 minutes. Okay. Okay, so let's do number 14. Oh, excuse me, not number 14, 13, 13, 14, 15. So 3 more questions. So we can finish the section here. Okay, so I think Mega Million Lottery is still play. I don't know, maybe not. Still play, okay. Powerball is still out there. Mega Million, let's see. All right, so you're picking 5 numbers from collection of 56 and Mega Ball number from collection of 46. Okay, and then it says order does not matter. So order of selection of 5 numbers does not matter. Okay, order does not matter. So no repetition. We don't pick the same number twice, so no repetition. And then no order. Okay, so we know it's a combination. That's clear. All right, so let's see. Jeremy, do you want to try?
I'm pretty sure I got it wrong.
Oh, you didn't use a combination?
No, I did not.
Okay. So you understand why I use combination. It says order does not matter, right? So I read. All right, so here is 2 groups. Group 1, it is a collection of 56 numbers. Group 2, it is a collection of 46 numbers. So here is a Mega Ball. And here is just a collection of 56 numbers. So it says you must pick 5 numbers from collection of 56. So 56 combination 5 and the 1 number from 46. Then we multiply. Okay, 2 groups. So 56 combination 5. 3, 8, 1, 9, 8, 1, 6 times 46. Okay. 175,711,536 ways to choose 5 numbers from collection of 56 and 1 Mega Ball number from collection of 46. Another way to say it is really hard to get that jackpot. Okay, it's hard to get that jackpot. Okay. If I have that money, I move this money to, okay. Annuity. Some people buy lottery ticket every day. Oh, I missed my ticket today, and that was my winning number and things like that. No, if I were you, I do not spend the money for buying lottery ticket every day, because if you know that chance, I'd rather put this money into annuity. All right, let's move to number 14. Any question on number 13? No question. Okay, let's move to 14. Exam consists of 20 multiple choice questions, 10 open-ended. You answered 15 of multiple choice, 5 of open-ended. This is similar to what Tyler did a few questions ago. So there are 2 groups. Here is multiple choice questions. Here's open-ended. And order does not matter. So it's a combination. 20, we pick 15 questions. And we have a 10 open-ended. We pick 5 of those. You multiply. Okay. So 20 combination 6. 15 rather. 20 combination 15. 10 combination 5. 252. And we always multiply in between. Okay, 2 groups. 3907008. Okay, 3,907,008 ways to answer these questions. Let's move to number 15. Okay. Okay, lucky draw cheats 10 names. Okay. Out of 3 were taken. Okay. No repetition. Does order matter? No order. Combination, here's a 10, you choose 3.
120.
120, thank you. So as you see, examples that we had for like a lot of examples today, we had a lot, okay? Not just problem 107, we also had previous problems.